purpose of this seminar is to provide information and details about the updated LMS infrastructure and about the TNA projects that we have completed. As far as some updates that we have in our infrastructure during the last months, we currently have a new cave system which consists of 3 large projection screens, 9 square meters total projection area, and it's supported by 3 high-spec barcode projectors. The motion tracking of the user is done through an optical tracking system consisting of 4 Vicon infrared cameras. We are also having 2 head-mounted displays, the new one, the Visor SX, and an older one, FS5. LMS PR, as far as the user's movement, is tracked using a magnetic tracking system, Polyhumous Fast Track, and we also have 2 immersion cyber gloves, where one of them is a cyber touch. As for the LMS Holo infrastructure, it's based on a neon eye crystal holographic device that allows the 3D visualization of virtual objects using a 50-inch LCD high-definition projection screen, and the holographic image is visible from a wide field of view. We are also having the Vuzix Star glasses, which are used for augmented reality application, and these glasses use optical see-through projection technology. Those 2 platforms, the LMS VR and LMS Holo, are supported by several workstations that you can see here. And it's also supported by commercial software packages such as the Virtuals, the Quest 3D, the EO Studio, and the Elmi and CATIA software. After this short presentation of our infrastructure, we can move on to the 2 TNAs projects that they were completed so far. In the LMS Holo infrastructure, the first one was from Technical University of Chemnitz, the development of immersive testing environment, and the second was from Center for Usability Research and Engineering, the user evaluation of 2 interaction methods. Those 2 TNAs are complementary to each other since the second one continues the work of the first one. So we start with the TNA 134, the development of an interaction techniques testing environment for Internet of Things application. The objective of this project was to develop a virtual environment in order to test various interaction techniques with different users and for deriving conclusions on the usability of devices and methods for the factors of the future. The development includes the incorporation of low-cost interaction devices such as the Wii Balance Board and Microsoft Kinect, and the output was to have an immersive environment that will help the design of future interfaces for the factors of the future based on usability and trust tests that can be carried out. Continuing, when we're evaluating interactive technology, such as mobile applications, in terms of usability, both researchers and practitioners, they need to make some choices. These choices, for example, is about the number of study participants, the selection of methods, and of course the duration of the evaluation. An important decision also in such an evaluation is about the environment. For example, in mobile usability evaluations, participants have to interact with the mobile technologies, for example, a smartphone or a tablet, and they have to move through the virtual world hands-free. This has as an immediate effect that devices like a fly stick, they cannot be used. So, for this reason, there have to be implemented navigation methods to be hands-free that feel natural and provide a high feeling of presence for the participants. So the challenge is a creation of an immersive environment capable of testing usability and trust levels of interaction techniques. This developed environment has to be compatible with different interaction methods and devices, and they should lead to a setup for an evaluation environment where conclusions on usability and trust levels can be derived. The work description that this TNA took place had 4 different steps. The task 1 and task 2 about the design of virtual environment and preparation of data and development tools took place before the user came to our infrastructures, and then we followed on with the development of the virtual environment and the setup of interaction devices. As far as the setup about the visualization, a mixed reality setup was used, which included the star see-through glasses, and a powerful setup was used. As far as the VR software, the instant reality that is developed by Fraunhofer was used, and for the interaction, a smartphone and tablet was also used. The two virtual environments that they were developed was a business environment, as you can see in the first picture, and a house environment. As far as the navigation, the first navigation method uses the Wii balance board that has 4 pressure sensors that are situated in each corner, and they detect the weight the user puts on them. So, in order to control the speed, you use the back and front balance, and in order to control the direction, you use the right and left balance. All this data is transmitted via Bluetooth using the library that's provided by Wii, and the data is transmitted to instant reality software, so the movement is performed. The second navigation method uses the Kinect sensor, the Microsoft Kinect. So, in order to do the navigation, the participants put the right foot in front in order to move forward, and they put the right foot back in order to move backward. As far as for rotation, the participants need to turn their shoulders. So, the more the participants turn, the faster they rotate. So, if they move left and right their shoulders, they move accordingly. And the speed is calculated using trigonometry as it's indicated in the figure. This is the setup. So we had a mix and a virtual reality immersion with the glasses and with the powerball. We had as application interaction the tablet and the smartphone. And for our navigation methods, we had the balance board and the Kinect. So about the results of the first TNA, the delivery environments give the ability first to conduct user tests for different interaction methods, and second, to use the results and the conclusion of this test in order to better select design interaction methods for use cases related to the Internet of Things. Now we move on to the next TNA 135, which is the presence and usability in virtual environments from CURE, the Center for Usability Research and Engineering, that they use the work from the first TNA, the two environments and the interaction methods developed, in order to do the user evaluation. As far as the objective was to learn about the presence of the two virtual environments and the effects that they have on usability. They try to answer questions like if the experience, presence, and usability differ between the powerwall and the HMD, and if the level of presence has effect on factors of usability. So they try to compare the presence and its effect on usability of those two developed environments. Following the challenges that they face, since it was not very clear, first of all, if, to which extent and under which situations the level of the user's presence in different VR technologies varies, and what effect this has on the perceived usability. So, the challenge was the comparison of VR technologies with the real-world experiences. For example, when studying and evaluating interactive technology, such as mobile applications or other applications in the Internet of Things, for first of all their usability and second for the user experience, researchers and practitioners have to make some choices. For example, as far as the laboratory and field usability studies that they may use, both of them they have some strengths and weaknesses. For example, the field studies, they said that they lack experimental control, and on the other hand, laboratory studies said to be less ecologically valid as they provide less realistic experiences to participants. To continue, the strategy was to improve the disadvantages of field trials in terms of experimental control by using virtual environments. The challenge was to create enough presence for the test participants in order to avoid a laboratory-like setting, and in order to get valid results about the usability and the user experience. As far as the work description of the second TNA, 3 different steps: preparation of user study, the setup of user study scenario, and the user study with 32 participants. Some information about the effect of presence on virtual environment and what they used during the evaluation. One of the most common methods for measuring presence are the post-test questionnaires and rating scales such as the ITC SOPI, which is it's reliable, and it was developed for assessing presence regarding interactive displays or other types of media like virtual environments, and consists of 44 items and 4 factors such as the sense of physical space, the engagement, ecological validity, and negative effect. The level of immersions in different virtual environments has a major influence on presence and depends on the hardware that is used and the quality of the virtual environment. So, for example, by having a larger field of view, high resolution images, object details and size, all these are important factors for the presence in the virtual environments. As far as the effect of navigation on virtual environments, several factors, some of them that influence presence are the display parameters, the sound, the body engagements, and the navigation method. So the participants, for example, that use walking in place, they have reported significantly higher sense of presence than those that use the mouse button to indicate walking. As for the study setup, the participants move through the virtual world hands-free, and they conduct different tasks with a security assistant interface that informs the users about the handling of the personal data in the 2 scenarios. And they were using it through the smartphone or the tablet. So, the language of the study was Greek. The research question they tried to answer was to examine if the kind of virtual environment, the Powerball or the mixed reality, and the navigation method, the balance board or the Kinect, has a significant effect on the participants' reported presence. They made the following 3 hypotheses that they were posed. First of all, the first was the kind of virtual environment has a significant effect of presence, with mixed reality being more immersive and therefore having a higher presence. The second hypothesis was that the navigation method has a significant effect on presence, with the Kinect being more natural and therefore having a higher presence. And the third was that there is a significant interaction effect between the kind of virtual environment and the navigation method, indicating that these 2 factors are influencing each other. We followed next with the setup user evaluations that we had 32 participants divided in 4 groups. Each group was using a different setup. For example, group 1 did the test, the evaluation by using balance board mixed reality. The group 2 balance board and Powerball. Group 3 the Kinect and mixed reality, and the group 4 Kinect and Powerball. So we had 2 scenarios. In the smart office scenario, which was the first environment that was developed, the test participants had to conduct 2 tasks. The first was to find and navigate to an elevator, and the second to register to an electronic receptionist via the smartphone that they were holding. In the second scenario, the smart home environment, the participants had to conduct 2 tasks again. First was to navigate to a medical cabinet and open it, and the second to reorder medicine with a medical cabinet by using their tablet. So the procedure that the users followed during the evaluation, first we make them a short introduction, then they have to become familiar with the equipment, and then they perform the scenario execution, and at the end, when they finish, they completed the questionnaire. We move on and we see a short video of the users performing their test. It's a user that is in the smart home scenario and is trying to navigate and to find the medical cabinet in order to open it. He's using the Kinect in order to navigate. That's why he's putting his right foot in front. And here we just saw that they ordered the medicine by using the tablet. In this screen, we see the user again by using the Kinect and the Powerball to try to go inside this building and navigate to the elevator. It was the first task. And here we see the user that is inside the building and is trying to register to an electronic receptionist by holding the smartphone in order to interact. So, after conducting the tasks in both scenarios, all users were asked to answer the questionnaires, and the evaluations on these questions were based about the realistic feeling, the experience they had, if they occurred any simulation sickness, and the usability and trust during their test. Concluding, the results made by the user evaluation is that the user test allows to further develop new testing procedures for the usability and trust of interaction methods, and the results indicate that the combination of Powerwall for visualization and Kinect for navigation increases the presence of participants.
How many people did you test in the different configuration? Did you have the opportunity to have a real user study, or it was only testing with a specialist of immersive environment?
Actually, we had 32 people testing, and most of them were not familiar with virtual reality, okay. So they were novice in the technology.